So there's going to be lots of practical talks over the next 2 days. I hope this is viewed as an antidote to that. This talk is about the impact of the information age on the evolution of the corporation. Let's see if this thing works. Yes. So it might be a strange question to ask, but can a corporation have an IQ? And does the company you work for have a high IQ or a low IQ? If you were around in the industrial age, that would be an easy question to answer because the IQ of the company you work for would just simply have been the IQ of the person running it. That was sort of how things worked in those days. But what about now? Well, before I answer that question, let's just dive into a little bit of context setting. So the modern corporation as we know it today was really created to put lots and lots of people to work as labor in specialized tasks in places like this. This is the River Rouge plant at Dearborn, Michigan. I've been there. It's every bit as big as it looks. And it took a different kind of management style to manage something like that. The modern corporation drew its approach to management from bureaucracy. We're all familiar with the term. It's a very hated term. But it played an important role. We borrowed it from Napoleon's administration of government. And it came from the term desk. It actually means desk in French. And essentially what it was is it was a way to move information throughout an organization. Those large companies putting large quantities of labor to work were still essentially information processing engines, even though the primary output of what they did was coordinating labor. And the mechanism they used to do that looked like this. But bureaucracy was more than just sort of something that we could all live to hate. It was sort of the original stack of business, this original technology stack. It had database and file storage, message queuing, message processing, had all the things we think of today in an IT department. They were just implemented in a slightly different manner. And so at this stage of corporate evolution, going back to the idea, kind of the key idea here of making an analogy with evolution, is the corporation in the industrial age was about equivalent to the nematode, which is every neuroscientist's favorite worm. It's very plentiful, but has a simple enough nervous system that it's easy to understand. And in fact, nematode had about 300, typical nematode has about 302 neurons, only 20 of which are in its pharyngeal nervous system, which means essentially its brain. But yet with only 20 neurons in its brain, it's able to maintain homeostasis. It can move towards food. It can move away from things that it should avoid. And it's actually a pretty capable little animal, much like the original bureaucratic corporation, despite its limitations. Now, a nematode is not conscious of any of this stuff. The nematode's brain essentially works as a purely dispositional engine. It has certain dispositions, move towards food, move away from danger. And corporations are like that too. We essentially have, in bureaucracy, we coded in these reflexive responses. If a competitor lowers pricing, we lower pricing. If shelves go empty, we order more. These things were all built into the structure of that bureaucracy. Now, that started to change with the onset of the information age. In 1954, a guy in this picture named Joe Glickoff, who was at Arthur Andersen at the time, implemented the first payroll system, digital payroll system, on a UNIVAC 1 computer for General Electric. And this not only introduced the information age, it also introduced the corporate IT consulting industry, which over the next 30 or 40 years from then digitized lots and lots of functions within corporations. Now, just because everybody had a mainframe in the 1960s, 70s, and 80s doesn't mean they weren't still bureaucracies. We were essentially still running companies as though they were about hierarchy, specialization, and control. And if you have any familiar with early IT projects, they essentially looked like somebody dumped filing cabinets into database tables. The idea of database design at the time really boiled down to take the contents of your master files, et cetera, put them in database tables. We weren't really changing how things worked. We were just simply digitizing them. And in a sense, what we were doing is wiring that worm. We had this thing that's still basically a simple bureaucratic, reflexive, dispositional system, and we've digitized it. And when we did that, we made it more scalable, we made it more efficient, we made it more effective in a number of ways. Perhaps we've now upgraded it to a lizard brain from a worm brain, but it's essentially still that dispositional hierarchical thing. And so to summarize that, in a sense, bureaucracy is your company's lizard brain. Your CIO has spent 50 years digitizing it. Then about 30 years ago, these four gentlemen invented the network we now know as the Internet, and that began to have really significant impact on the organizations we all work for as of about the 1990s. And it happened like this. We started paying more attention to how we integrated with the rest of the world and less attention to how we managed our internal processes. And essentially what we've done is we've given these little worms, or now lizard brains, much greater reach. They're reaching deeper out into the world. We've given them language. They're speaking in XML to the rest of the world. They're experiencing much greater complexity by connecting to a much broader environment. And we're not just changing how they interact with the rest of the world, we're changing their internal wiring as well. Most companies, probably the companies you all work for, still officially publish an org chart that is a hierarchy, but more often than not, if you could look at the way emails pass around inside of the organization, if you could look at phone records, if you could look at the way communication actually occurs, you'd find out it looks more like the model in the middle, or perhaps even to the right. What happens is, based on need, new connections are formed in an organization. When that happens in a brain, that's called learning, and that's actually what's happening in our organizations as well. We're adding these ad hoc emergent networks on top of the official structures of our organization, and it is a process of learning the organizations are going through. And that's actually really important, because as we connect to a much broader world, the amount of intelligence required to operate these organizations is going up as well. It's no longer possible for the Ford at the top of the organization, or even a Steve Jobs anymore, to manage what these things do. The companies themselves, the organizations themselves, have to be smarter than the smartest person in them for this whole process to work anymore. Okay, so we've taken a quick tour through the industrial era and the first two epochs of the information age, sort of the computing and networking stage. And I hate to use the term big data, but it's the term that we use, so let's use it. This is a conference about big data. Over the next 3 days, we're going to be talking about architectures and systems and things that do analytics at scale. And my contention here is that as we enter into this area, it's going to have a huge impact on how the corporate organization, the corporate form that we all work for, evolves going forward. It's going to have a fundamental impact. And let me just kind of use this as a starting point to say why. If you look at intelligence in humans, the idea of IQ in humans, there's all kinds of things we measure when we give people IQ tests. But the number one thing that IQ correlates to is working memory. Everything else has various levels of correlation, but working memory, that ability to take in perception, maintain it in memory, and reason against it, is the fundamental idea of what IQ is about. And that reminds me of something, which is this picture, which probably doesn't mean much to anybody, but this is a snippet of a weblog. And in the 1990s, when companies were first installing web servers and doing things on the web, these were ephemeral pieces of data we kept around for just a little while, and we used them to troubleshoot broken web servers. Nowadays, we don't troubleshoot broken web servers, we just throw them away. But somewhere along the line, a lot of smart people realized that these things were actually much more relevant as working memory, as things to be stored and pull signal out of, than they were as troubleshooting guides. And now there are companies that, as you know, that have petabytes of this stuff laying around. And as important as the fact that they have petabytes of it is the fact that they can reason against it within very tight time cycles. And that was just the beginning. So organizations now are moving into perceiving all kinds of things in their environment. So we were perceiving things on the web. That's still very true. Although what's interesting, as was pointed out earlier, as more and more companies become digital businesses, it's not just web companies doing this. It's companies across all kinds of industries, financial services, et cetera, who are taking advantage of being able to use weblogs as a perception. But of course, there's also sensors on things like trains and jet engines, and there's as we give everybody in the world mobile phones, we're getting all kinds of sensory perception for our little lizard brain from that. GPS, we're even building products. I mean, people look at the Nest and they think it's a thermostat. It's actually an information gathering device, and it's filling somebody's servers up with information that can be used to do intelligent things. Down in the bottom corner is RFID. In addition to this perception, this whole conference is about the tools and techniques and architectures for how to reason against that stuff in real time. And so there's really something qualitatively different going on here. And it's similar to the qualitative leap that happened in mammals when we went from having pure dispositionally oriented lizard brains to having maps in our brains. So the parts of our brain that give us consciousness, the parts of our brains that give us the ability to think and plan farther out into the future, are not reactive and dispositional. They're based on our ability to map states of the external world into our brain. and use those maps as a foundation for reasoning against. And if you think about corporate organization, we've sort of like spent that first 50 years of doing payroll systems, et cetera, all those mainframe systems, were sort of about the internal state of an organization. They were, I like to say business intelligence is corporate kinesthesis. It's how the hand tells the head where it is and what it's doing. But that's changing with those perceptions that we're putting out into the world. The perceptions we're gathering from the world now, we're actually building really complicated, high-resolution states of the external world that we operate in. And the human brain actually still has different regions in it that are the early dispositional regions that are now, and also combined with these later map-based regions. And I'm just going to read this. The two spaces point to different ages in brain evolution, one in which dispositions suffice to guide adequate behavior, and another in which maps gave rise to images and into upgrade of behavior. Today they're seamlessly integrated. So 2 points there. One is, the old IT isn't going away. We're going to simply layer the stuff on it, and we're going to give ourselves, our organization's intelligence based on this new stuff. And it's going to be combined in very important ways. But it represents the possibility of a significant upgrade in behavior of the organization, and it also represents that behavior moving down into the machines in many cases, and no longer being just the purview of the people running it. So all organizations are seeing their IQ increase because of the adoption of these technologies. And the question for all of us is, how do we make sure our organization has a high IQ, or what do we even mean by that? And actually, I'll just throw out there, I think it would be a really fascinating question to ask yourself, if there was a corporate IT test, if there was a way to measure the IQ of a corporation, and your bonus was dependent on it going up every year in the same way that we currently tie our organizational incentives to financial measures, what would you do about it? That's sort of the core question here. So I talked about working memory as the primary correlate with IQ, but let's go through a little bit more of a model that just talks about what some of the more detailed kinds of things are in there as a way to just think through this. These are not in any sense well thought through. These are just sort of ideas to give a sense of what kinds of things we might be thinking about if we're trying to increase the IQ of an organization. So fluid intelligence is the intelligence that lets us deal with new, unexpected situations, form concepts, and do problem solving. In a traditional bureaucracy, this is completely the purview of the people running the company. The bureaucracy itself would have no encoded rules for dealing with this stuff. But today we're beginning to see techniques come into the organization, things like corporate DevOps and lean principles, things like faster cycle times, get things out there quickly, doing near real-time analysis and providing the tools for doing that. And in particular, providing collaborative information flows across the hierarchy that let people organize quickly to do this kind of problem solving. Crystallized intelligence is the kind of intelligence that's based on what we know and what we can do with it. Can we communicate it? Can we reason against it? Technologies that are supporting these kinds of things are things like IBM Watson, which is attempting to bring all medical information to doctors to make much more rapid diagnosis. Things like Wolfram Alpha, which bring in hundreds of data sources and provide a computational environment for doing things with it immediately. Even something like Google's PageRank is essentially crystallized information, crystallized intelligence made available. It's taking all the links that we put on the internet as crystallized information and reasoning against them to tell us what priority we should show results or Google should show results. And as we deal with more and more unstructured data, the kind of entity extraction techniques that we might use that will be talked about in a conference like this become part of that picture as well. Quantitative reasoning, I think this is fairly well understood. Banks are already doing things like Monte Carlo simulations at large scale. We're beginning to bring machine learning and classification into a lot of organizations. We talked a bit about short-term and long-term memory already. I think the main point I wanted to make here was just that many organizations are putting a lot of thought into how to handle the deluge of data that combines both traditional transactional data plus all this new perception data coming from the environment, plus a lot of unstructured data, and putting it together in ways that you can actually reason against it in real time. What are your internal or external API strategies so that you can share that information? How do you make sure it gets out of the departments it was created and that sort of thing? These are all core components of IQ for an organization. And then in the human context, processing speed and decision speed usually mean how we make decisions or how we process data at slightly different time cycles. There's a similar way to think about it here in terms of operational versus tactical or strategic timescales. But essentially, things that will improve human collaboration, things that embed analytics directly into our technology so that decisions can be made in real time without human intervention. So for example, like automated trading, those kinds of things. And kind of symbiotic workflows are important for adding IQ in this area. Okay, so the takeaway from looking at these is not that this is a prescription for how to increase the IQ, but it's maybe a way to think about the analog between human IQ and corporate IQ and begin to think through what some of those are. I actually left out a few of them. The actual sort of theory here includes a bunch of others that didn't seem to apply as directly to organizations, so I left them out. But there are probably others that I haven't included that should be included. But one takeaway here is that there are still things that humans are good at, and there are things that machines are really good at. And when a bunch of good chess players combined with a bunch of good computers play either a really, really great chess player or a really, really great computer, they always win. And so the takeaway here is that corporate intelligence is still going to be a symbiotic thing that we achieve through a combination of human and technology. And the last thing I'm going to say is that it's been 100 years of thinking about human IQ. We still haven't agreed on what it actually means. We think it means different things in different places. We can't agree exactly on what the rules are for it. But we do know that we all would like to be smarter, and we want our organizations to be smarter because, as is pointed out in the earlier conversation, being faster and smarter is going to be the organization that wins. So I think I've actually left time on the table for somebody next. Thank you very much.